How AI servers actually work. When you type a message into an AI chatbot, it doesn't actually read words the way humans do. Instead, your text is broken down into small pieces called tokens. Each token is converted into thousands of numbers that represent its meaning. You can think of each token as a point in a space with 2,000 to 8,000 dimensions. Every token becomes a large collection of numerical data that the AI can understand. Now imagine a long conversation. The AI isn't just processing your latest message. It also has to keep track of previous messages, its own responses, uploaded files, and any reference material. All of this fits inside what's called the context window. Today's most advanced AI models can have context windows ranging from hundreds of thousands to over 1 million tokens. That means the AI may be processing the equivalent of several gigabytes of numerical data for a single conversation. To generate a response quickly, the AI passes all of that data through dozens or even hundreds of neural network layers. At every layer, billions or even trillions of model parameters help determine the next token to generate. Modern AI models are enormous. Just storing the model for inference can require more than 20 terabytes of memory. During training, the total storage needed can easily exceed 100 terabytes. So where is all of this data stored, and how does it move through the system? Let's start with long-term storage. Large AI data centers store massive collections of training data, including text, images, videos, audio, and other multimodal content gathered from many different sources. They also store training logs, model checkpoints, and other supporting data. This massive knowledge repository is typically stored on enterprise-grade solid-state drives with capacities of up to 122 or even 246 terabytes each. A single server rack can hold tens or even hundreds of petabytes of storage. However, long-term storage is too slow for AI training. Instead, the training data and model files are first loaded onto high-performance SSDs installed directly inside the AI server. These SSDs use advanced PCIe 6.0 connections to deliver data at speeds of tens of gigabytes per second. That sounds incredibly fast, but it's still much slower than what modern GPUs need. A high-end GPU can consume data at over 1.2 terabytes per second, which is more than 1,000 gigabytes every second. To keep up with that demand, AI servers rely on large amounts of high-speed system memory. Using DDR5 memory, each memory channel can transfer roughly 90 to 100 gigabytes per second, while maintaining extremely low latency. In a typical AI blade server, you might find 32 DDR5 memory modules, each with a capacity of 128 gigabytes, providing a total of about 4 terabytes of system memory. During training or inference, the CPU loads model parameters, training samples, and token data from the SSDs into system memory. Once the GPU is ready, the data is transferred over a high-speed bus into the GPU's dedicated memory, known as VRAM. Modern AI GPUs use high-bandwidth memory, or HBM. Each HBM package is made by stacking multiple memory chips vertically and connecting them using tiny vertical electrical pathways called through-silicon vias. Typically, a GPU is surrounded by 6 or more HBM memory stacks, providing over 140 gigabytes of ultra-fast memory. The GPU and its HBM memory are mounted together on a component called an interposer, which acts like a miniature circuit board with extremely dense wiring. This design allows the GPU and memory to communicate at speeds of around 1.2 terabytes per second. With that enormous bandwidth, the GPU can continuously receive the data it needs to perform AI training and generate responses. But one server isn't enough to train today's largest AI models. Modern AI data centers often contain dozens or even hundreds of server racks, housing thousands of GPU-equipped blade servers. These servers are connected using ultra-fast networking, creating one massive supercomputer. When a model is trained, the workload is divided into millions of smaller tasks and distributed across thousands of GPUs, all working in parallel. So when you ask an AI a question, your request travels to this giant computing system. Thousands of processors work together behind the scenes, and within seconds, they produce the response that appears on your screen. Every answer is the result of a data center-sized supercomputer working together in real time.